This is Will Weathers with Finished Thompson, here to look at the system. We'll also do a little troubleshooting and maintenance procedures on the pump. So what you've got here, you've got 4 SP self-priming centrifugal pumps. Black material means they're PVDF. There's 1.5 horsepower. The pumps are pumping, pulling prime, pumping over to the analyzers, through the analyzer system, and recirculating. Pumps are pretty simple. On startup, first thing you want to do, make sure the valves are open. So we're going to open the suction valve, we're going to open the discharge valve. Before you do anything, you want to be sure the pump has liquid in it. These are self-priming pumps, but the pump has to be filled. So this is your drain plug. You want to keep it closed. Open up your fill plug, put liquid in the pump if it's not already there. Close the fill plug. Now the pump itself is primed. The pump will prime the line. So the next step, once you've got the valves open, would be to turn the disconnect on. Turn the disconnect on to engage power to the starter. The remote switch, on switch, you would turn the remote on switch on and begin pumping. Typically when you start the pump up the first time, you want to have the discharge valve partially closed. That allows us to be sure we have back pressure on the pump when it starts up. After you get the pump primed, then you would open up the valve and let it run full flow. So any back pressure that's here would be generated by the analyzer system as far as back pressure on the pump. The pumps here have been primed. We have primed the pumps, we have run the pumps, made sure the lines were drained, made sure we got all the air out, and the pumps did develop flow. So I'm going to close the discharge and close the suction. And then of course we would come over and turn the disconnect off if you were done, but assume these are going to run full time. Now as far as the pump's concerned, it's pretty straightforward. I have a pump here. So again, this is a self-priming pump. That's the reason for this chamber. It holds liquid so that the impeller inside the pump has liquid to begin the priming. So basically the impeller recirculates the fluid inside the pump. The air evacuates out here. The air always goes to the highest point. Liquid would come in, again recirculate until we get all of the air out of the suction side. Once we get all the air out of the suction side, now the pump will pump fluid and build pressure. So it's a mag drive centrifugal pump. So on the back side of this pump, the first thing you're going to notice, there's no shaft coming out of the back of the pump like your typical sealed pump. Okay, this is what we call the drive magnet. So this magnet would be connected to your motor. Inside the pump, this is just your open cavity to hold your liquid. This is a diffuser plate. What this does, as the liquid is pulled in, the liquid and the air, the mixed media, comes out. This just helps separate the air from the liquid. The air goes up, the liquid drops back in, and it recirculates. So that would come off. This is called the volute. Because we have an open housing here, this would be the volute of the pump. Real easy to get it off. It's held on. We do not want any metal fasteners in here in case we were pumping chemicals. I think you have one of those as well. But what we're going to do is I'm going to get the volute off. So these clips would get the volute off. So all I'm going to do is I'm going to pull on this clip and pull on the volute at the same time, lift up and just disengage that clip. I'm going to disengage that clip and disengage that clip, and then I'm just going to pull straight off, and I just pulled the volute off the pump. So now we have the volute in our hand, we have the shaft, we have the impeller magnet. This is called the barrier, or sometimes it's called the containment shell, or the barrier. Okay, and what it does, it keeps the fluid coming out. There is a static O-ring. When the housing goes on, that O-ring is what keeps the pump from leaking. So you have a shaft. You can see the 2 flats on the shaft. Those 2 flats match the 2 flats inside the pump. So we put the shaft in. The shaft doesn't spin, it stays stationary. Then this is your impeller, and underneath this plastic are magnets. This bushing is a wear item, so this may be a replaceable wear item. So this bushing is what rides and keeps the impeller running true inside the pump. So we run that bushing, put it on the shaft, and for lack of better words, it's floating there. Okay. Then we would take the volute, we're going to put it back on. Now you'll notice there's 3, they're all offset, so this will only go back on one way. So we've got to turn it until we find where all of the clips match up. So I'm going to engage 2 clips, and then the 3rd clip I'll have to pull out by hand. And get it partially engaged. So you can see all 3 clips are partially engaged. Then I just push straight down and it snaps in place. So that just put the volute back on the pump. Then I'm going to take the separator plate, I'm going to put it back on, and then you'll notice inside the volute, inside the housing, there's a guide which matches up with this slot. So I'm going to take the housing, I'm going to line that up, put the housing back on, put the bolts back on. Okay, so I've just reassembled the pump. On the back side, you have an adapter. This adapter adapts your pump to your motor. You may have a 56 C-frame motor in this case. There may be other pumps here with other motors. All this does is adapts the pump to whichever motor you have to make sure the bolt pattern is correct. So you would put this on, you'd engage 4 bolts here. Okay. Once those bolts are on, your motor would have this piece on this set of drive magnet on the motor shaft. So when you're putting this on the motor shaft, you have to be sure it's at the right place on the motor shaft. So when you put this together and bolt your motor on, this is in the correct position to make the pump work the way it's supposed to. So what we've done, if you look in the bottom of this bore, you can see there's a snap ring in there. Okay, you can see it from this side as well. So what you do is you slide this up on the motor shaft until it bottoms out against that snap ring, and then you tighten your set screws. Once you tighten your set screws on the motor shaft, again, make sure it's bottomed out. If my arm were the motor, this would slide up, slide in here, and bolt the motor on, and now you've got a complete pump as you saw earlier. Okay. So then, as the motor turns on, it begins to turn this piece here. So this is your drive magnet. It begins to turn the drive magnet. And when it turns the drive magnet through magnetism, it's turning the impeller on the inside of the pump. That's the way it works. Therefore, you have no seal for maintenance purposes. The biggest maintenance items you would have are the bushing, if it begins to wear, or what we call the thrust ring, which is on the front of the impeller. Those are the 2 main wear items, and a new O-ring. So other than that, that's pretty much the maintenance of the pump.